Welcome back. Are you enjoying yourself so far? Oh, wonderful. How many of you are here for the first time? Oh, I love seeing that. Welcome, welcome, welcome. How many of you will be coming back next year? All right, I hold you to it. I hope that's a promise. I had a chance to talk to you this morning about how we're not computer scientists and we're not software engineers, we're storytellers. Well, let's tell stories about JavaScript in here. As I said, my name is Scott Davis. I run a consultancy out of Denver, Colorado called ThirstyHead.com. I also run the HTML5 Denver user group. And what's interesting about web development is that there are so many different languages. If you come to HTML5 Denver, you'll hear stories about CSS. You'll hear stories about JavaScript and different frameworks and different build tools and different testing infrastructure and all kinds of different things. It's kind of a nice broad umbrella term. But one thing that remains constant through all of that is we need some way to present the data. And that, of course, is our HTML. We need some way to format the data in a nice declarative way, that's CSS. And we need some way to provide behavior, and of course that's JavaScript. So what we're here to learn about is all of the new features in JavaScript that you may not know are already in your browser waiting for you to take advantage of it. So I've been talking a lot about the mean stack in recent years. How many of you use the mean stack? Show of hands, how many of you have any idea what I'm talking about, the mean stack? If I say the lamp stack, have you worked with the lamp stack before, familiar with that? Yes, it's a way of describing kind of in generic terms the technology stack you're using. The lamp stack, of course, is Linux for the operating system, Apache for your web server, MySQL for the database, and Perl or Python or PHP for your view technology. It's amazing. In this video I shot for O'Reilly, the most comments I got on that video is what the P actually stood for in LAMP. I had to say, not the point of the video, right? We're not here to talk about the LAMP stack, we're here to talk about the mean stack, and mean is short for MongoDB for your database, and Express.js for your web server, AngularJS for your front end, and Node.js for your platform. Why am I pausing here talking about the mean stack when we're supposed to be talking about JavaScript? Well, what's interesting about the mean stack is that it's all JavaScript. The mean stack is one of the first times where we get the opportunity to use JavaScript in the client, through AngularJS, of course, and JavaScript in general. We get to use it on the server. Node.js is a JavaScript runtime. Express.js is a web server implemented in JavaScript. So we have the same language running in the browser that we do up on the server. And oh, by the way, MongoDB, that's JavaScript as well. It stores all of its data in JSON, which of course is JavaScript object notation. That's a bit of a lie. It stores it in Bison, which is binary JSON, but you get the idea. It stores its data as JSON. We use JavaScript to access it. We use MapReduce functions and good things there. So the mean stack should be especially interesting to us these days because it's the first time we get to use JavaScript in all tiers of our application. It's exciting stuff. So what we're going to talk about today is ECMAScript 6, but in order to do that, we've got to kind of talk about what ECMAScript 6 is, right? And we'll certainly get to all of the cool new language features in ES6. There are some new methods around strings. We have new array-like objects. Algebraic data sets are what they called sets and maps. We have constants, we have new keywords like let, and oh yeah, we have classes and modules. So we have a lot of good stuff to cover. But I want to start with this. A slide from the Angular 2 team way back in 2014 when they announced the project. Have you heard that Angular 2 finally went final? It went final within the last 24 hours. We finally have an Angular 2 framework. How many of you are Angular developers in here? A few? Okay, very good, yes. So when the Angular team was talking about their plans for Angular 2, because Angular 1 came out in 2009, it's been remarkably stable all these years, and it's really typically number 1 or number 2 in terms of frameworks. It tends to jockey back and forth with Backbone.js in terms of what the number 1 framework is. There are lots of exciting new frameworks out like React, like things like that, but they tend to have a very small market share. Angular tends to be the 800-pound gorilla in the room. So when the Angular team said, we're planning out this new framework, and one of the things we want to do, I love this particular turn of phrase, we're designing Angular 2 for the way the world will look when we believe folks will use it. If you had a chance to sit in on Scotty's talk, the selfie programmer, he talked about how hard it is to predict the future. And it is hard to predict the future. But the Angular team said, you know, this new ES6, ECMAScript 6, is on its way. And we want to have our framework in place by the time ES6 lands so we can start taking advantage of all these new language features. Const, let, classes, modules, things like that. So oftentimes when you're looking at Angular 2 syntax, and if you're looking at Angular 2 syntax, you might be wrinkling your nose a little bit saying, I don't have any idea what they're talking about. I know everything about Angular 1 and now Angular 2 comes out and all hope is lost. Well, no, not all hope is lost. They're embracing what they thought the future would look like, which is ECMAScript 6, which is JavaScript. As a matter of fact, as additional frameworks update themselves, the Reacts and the Knockouts and the jQueries of the world, as they upgrade, they're going to start looking more and more like Angular 2. Not because Angular 2 is all that special, because Angular 2 uses ES6. So I should pause for a moment here and ask, how many of you are using ECMAScript 6 or any of these new JavaScript functions? A few hands go up. Wonderful. You are in exactly the right spot then. So, this is the syntax we're going to cover. Strings, maps, set, constants, lets, destructuring, fat arrows, all kinds of good things like that. And we'll wrap up talking about classes and modules and imports and exports. But really, syntax is only half of the story. We're going to leave much of this syntax to later in the presentation because we want to make sure we understand more than just the syntax, more than just the curly braces and semicolons. We want to make sure we understand the semantics behind all this as well. So we've got a lot of ground to cover and not much time. So why don't we go ahead and dive in? You know that I'm a big fan of tests, right? And I'm glad that y'all are writing unit tests. As a matter of fact, I find that's the perfect way to learn new language features, learn new frameworks, is to turn around and write a bunch of unit tests. Because at some point, what your unit tests are simply executable documentation. This is proving it in code. So if you go out to my GitHub repo, ThirstyHead, that's my consultancy. If you go to github.com/ThirstyHead, you'll see lots of different repos out there where I'm just exploring new languages. I'm exploring internationalization in Grails, or in this case, ES6 tests. So I encourage you to check out this repo because it's many of the code examples you'll see in this presentation, but they're tests. So you can turn around and run them. And this is the value of executable documentation. I was the architect on the Samsung Smart TV project for Time Warner Cable. We put together a team, we worked on it for a couple of years. Now when you go out and buy a Samsung TV, hang it on your wall, and click on that Time Warner Cable icon, that is all HTML5. That's all Backbone, that's all jQuery, it's all manner of things. But what we ended up doing was having to test the capabilities of the Samsung browser. And so we wrote a set of tests that we could execute on the Samsung browser. And after we ran those tests, we knew what that browser could do. And then you know what we did with those tests? We ran it in an LG browser. And then we ran it in a Sony browser. Then we ran it in a Panasonic browser. It's a way that we could make sure that our corpus of knowledge, our understanding of what JavaScript can do, would run in those various environments. That's why unit tests are such a brilliant, brilliant way to test out language functionality, framework functionality, and in our case, platform functionality. Because once I have these unit tests, I can run them in any browser. I can see if it runs in the latest Android browser and the earliest Android browser. I can run it in the latest iOS 10, and I can run it on my beloved iPhone 1 that I bought almost 10 years ago. And so having this executable documentation, I think, will be a valuable tool for you, not in the short term, but in the long term as well. Does that make sense? So I encourage you to check out this code base, but more importantly, I encourage you to write your own unit tests as you're exploring new language features to make sure you have that executable documentation in your back pocket as well. All right. So what we'll end up talking about here are many of these tests that do pass. We see things like constants and fat arrows and let statements and maps and sets. So we do have syntax that we need to get into. But again, let's lay a good foundation first. Let's make sure we've got a good base understanding of what we're talking about before we get to the good stuff. Been mentioning ECMAScript an awful lot here. It almost sounds like a skin disease, doesn't it? Yeah, no, it's not a skin disease. ECMA is the European Computer Manufacturers Association. It's the standards body that ratifies and releases new versions of JavaScript. Now, one of the things you've got to realize is JavaScript was written by Brendan Eich at Netscape back in the mid-1990s. He was the language founder. He worked a whole 2 weeks on the language before it went final. Do you believe that? The jokes just write themselves, don't they? He could have used a few more unit tests in that first version, couldn't he? But over time, what we've found is that the standards body says this is what we think the new features of this new programming language should be, and the various browsers turn around and implement them. I tend to use the documentation from the Mozilla Developer Network, MDN, to keep track of all these new language features. So many of the code examples you'll see up on screen are from Mozilla. So those are my two kind of sources of truth. I look to ECMA to tell me what the language should do, and then I read up on MDN to see how the language has actually been implemented. But this is important, this idea of understanding ECMA, the spec, and JavaScript, the implementation, because there are several other ES implementations out there. Have any of you done any Flash development in your history? Any ActionScript? Yes, ActionScript is an ECMA-based language as well, isn't it? Did it seem very JavaScript-like? Yeah? Yeah, probably JavaScript is one important feature, one important difference. We'll talk about that. It's strong data types. It's static data typing. We'll get to that. But for right now, we understand that when we're talking about ECMAScript, we're talking about JavaScript. We're just using a different name. One name is for the specification and the other is for the reference implementation. Does that make sense? Yeah? Outstanding. So ES1 came out in 1997. Now, Netscape Navigator was released in 1995, and that's where the first version of JavaScript was introduced. As a matter of fact, when Brendan Eich was writing it, he was calling this Mocha as the key word. How many of you use Mocha as a testing framework right now? It has nothing to do with Brendan Eich, what was used doing in 1995. But it is a testing framework written in JavaScript that either inadvertently or vertently, purposely, chose the keyword or the code name for JavaScript as being developed. But it didn't last as Mocha very long. Right as it was going out, when Netscape Navigator 2 beta hit the market, it was called LiveScript. Do any of you remember a server project that Netscape offered called Live Server? You're nodding your head, yes. You've got the same amount of gray hair in your beard as I have in mine, so yes. We absolutely remember those days. So Live Server was much like Node.js. It was this radical notion that you could run JavaScript natively on a server. That'll never work, will it? Or maybe it will. Maybe we call that Node.js now, right? But when LiveScript came out, it was a part of the Live Server product suite. It was a scripting language you could run in a server and in a browser. Again, that should sound very familiar. But in between Netscape Navigator 2 beta being released and the final release, Netscape formed a strategic alliance with Sun Microsystems, the company behind Java. And for purely marketing reasons, in between the beta release and the final release, they renamed LiveScript to JavaScript. And any of you who know Java, and any of you who know JavaScript, know the two have almost nothing to do with each other, don't they? I like saying that Java is to JavaScript as ham is to hamster. In that they share a few key letters between them, but otherwise they're completely unrelated. Yes? So, when Netscape Navigator 2 came out in 1995, they released JavaScript. Microsoft came out the year later, and they wanted to do a clean room implementation of this, but they couldn't call it JavaScript because that was a trademark. And Sun Microsystems didn't grant them the trademark to the name that they granted Netscape. So what did Microsoft do to solve that problem? What did they call their implementation of JavaScript? JScript. Yes. So we had JavaScript and JScript. And if you were doing web development in the bad old days, and they were the bad old days, weren't they? Netscape would add a feature, and then Microsoft would copy that feature and add their own feature, and Microsoft would add that feature and add their own feature. And they were running as quickly as they could away from each other. No one won then, did they? So very quickly after Microsoft and Netscape were jockeying back and forth, they approached the W3C, the World Wide Web Consortium, the standards body behind HTML and CSS. And they say, would you ratify JavaScript as well? And they said, no. Really? They said, yes, we're a standards body, but we focus on documents. So the W3C is where you go for your standards for HTML and CSS, for XML, for XQuery and XLink and all kinds of things like that, but they didn't want to ratify JavaScript, a scripting language. So we have ECMA ratifying JavaScript, we have the W3C ratifying HTML and CSS and other various browser standards. So ECMA in 1997 introduced ES1 as a way to help get Microsoft and Netscape back towards working towards a common goal. And they released versions of ECMAScript in a fairly short order. ES2 came out a year later in 1998. ES3 came out a year later in 1999. And then nothing. I mean, nothing for years. Like, oh my gosh, I think JavaScript might be dead. That's how long it took for them to release the next version, ES5. How are your math skills? It's pretty simple, isn't it? We have ES1, ES2, ES3, ES5. Any questions? Oh, it's not that late, is it? Yeah, where's ES4? Well, what's funny, ES4 never materialized. It never shipped. But ES5 came out in 2009. So almost 10 years after ES3 was released, ES4 was abandoned and ES5 came out. And then ES6, ECMAScript 6, came out last summer. And I'm here to tell you that ES6 is probably the most significant release of the language since ES1. They have added so many new language features. They have added so many new language constructs that this is one that we're going to be talking about for quite some time. So how come we're not all raising our hands? How come we're not saying, this is great, I downloaded and installed ES6 the first day it was available? How many of you downloaded and installed JavaScript? What? You don't? Yeah, that's the problem with JavaScript, isn't it? It's just baked into your browser. You ask people what version of JavaScript they're using, and they say Internet Explorer 11. I say, no, JavaScript. And they say Safari 10. And I get it, yeah. So when these new versions of JavaScript ship silently with your modern browser, if you're not paying attention, if you're not plugged in, if you're not actively looking for those new features, you can miss it. And so many people did. Here we are over a year later, and they say, wow, ES6, that sounds interesting. When's it going to ship? Oh, yeah, a year ago, yeah. So before we get to the cool stuff in ES6, we need to talk about ES4, that abandoned one, the one that didn't quite make it. And if you look at the feature set of ES4, they introduced classes and a module system. Does that sound familiar? Does that sound like features that got introduced in ES6? Yeah. They introduce generators and iterators. They introduce destructuring algebraic data types. Those are those maps and sets. So this bullet list up here is essentially the feature list for ES6, with one important exception. What did I skip over in that list? Static typing. And that was the straw that broke the camel's back. That's why we can't have nice things, or at least we can't have ES4. Because JavaScript is a dynamic language at its core. And what we mean by that is you var up your variables. Var name equals Scott. Var age equals 46. Right? Var married equals true. So we have variables that aren't strongly typed. We just have a bucket that we pour that data into. And whatever shape data we pour into that bucket, JavaScript variables are happy with that. They're dynamic variables or untyped variables. We also have strongly typed programming languages like Java, like C#, where you can't say var name equals Scott, you have to say string name equals Scott. You can't say var age, you have to say int age, or float age, or double age. You can't say married equals true. You have to say Boolean married equals true. And so when Adobe, who is the company behind ActionScript, which is a language that is derived from ECMAScript, they had an incredibly fast JavaScript runtime. They had an incredibly fast compiler. And they were going to donate it to the Mozilla Foundation. They say, here, take it. This is fast. This is new. This is modern. One important thing, you got to use data types in order to get that speed. And that was going to break the internet. Think about all the code out there that was using var, var, var that would now need to start using string, 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 or int, 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 or Boolean, Boolean, Boolean. And so in fact, that one tiny little caveat, static typing, is what killed this whole project. It was very acrimonious. It was very, very heated. And so they've codenamed ECMAScript 6, ES6, Harmony, to try to bring all these parties back together to start saying, yes, it's going to be okay. You get all these things except static typing. But we're going to bring all these things back, and we're all going to agree that that's good enough, and we can call that JavaScript 6 or ES6 moving forward. Makes sense? Yeah? Good. Because now we have this thing called TypeScript. If you enjoy types, read the name of this programming language. Now read it again more slowly. Now start at the very beginning. Stop! TypeScript is actually a Microsoft project. Angular 2 was written in TypeScript. You read every book on Angular 2 out there right now, every single one of them, to a book is implemented in TypeScript. So if you like strong static typing, I encourage you to check out TypeScript. Microsoft and Google are collaborating on this. This is a key part of Angular 2. And this is what your world ends up looking like then. We have ES5, and then we have ES6, which is a perfect superset of ES5. All those ES5 language features plus all the features we're going to talk about. And then you have TypeScript on top of that. So if you like static typing, if you like interfaces, if you like method signatures that feature data types, TypeScript you're going to really enjoy. But you have to realize that just like generics in Java, type erasure, right? That is a language feature, not a runtime feature. All of that data typing that you do in Java gets stripped away in the runtime, doesn't get carried forward in the bytecode. The same is true. TypeScript should be a developer convenience. It should be an IDE convenience. If you want that kind of static type checking, you'll get it. But all that will be stripped away from the runtime. You will essentially end up being running ES5 or ES6 at the end of the day. So something to keep in mind as you're moving forward. All right. So this is an Angular 2 Hello World. You didn't think this was an Angular talk, did you? Ha! Surprise! Right? You look at this Hello World and you start saying to yourself, wait a second. I don't recognize any of that. Or maybe I do from a different language. When you say import component from Angular 2 Core, you say, wait a second. What language am I in? Yeah, this is JavaScript. At component, wait a second, I recognize those as annotations from Java. What language is this? Yeah, this is JavaScript. Yeah. Yeah. Class, app component. Wait a second, export class. Yeah. All this is ES6. All of this is ECMAScript 6. None of this is Angular specific. All of your frameworks are going to end up looking like this moving forward. I told you one brief lie, and that at over there, those are decorators in JavaScript, and technically that's an ES7 feature. So I did lie to you once, but it was a little white lie. The rest of these are ES6 features. Import, export, class, all those are plain old JavaScript. Nothing to do with Angular at all. The way you'll end up using this in the real world is you'll end up using a source-to-source compiler. Normally a compiler takes source code and gives you executable code at the other end, bytecode, right? But JavaScript isn't compiled. So what we need to do is we need to take some language that you're writing and translate it to another language so it can run in the browser. And so we aren't really dealing with a compiler at this point. We're dealing with a transcompiler or a transpiler. And so if you're running TypeScript, you'll use the TypeScript transpiler to take all that strongly typed code that you write and transpile it into ES6 or ES5. If you're writing ES6, nowadays you'll probably still end up transpiling that to ES5. So being able to talk about transpiling code, any of you do any CoffeeScript development? There are hundreds of languages that compile to JavaScript as a target. CoffeeScript, TypeScript, ClojureScript, they all are transpilers. All right. Tracer is one transpiler that was out there, and this is a Google project. It had a lot of early buzz, but I'm telling you right now, all the cool kids are using Babel. You're using Babel.js, and so Babel is a JavaScript compiler. You use next generation JavaScript today. All the keywords are there, all the buzzwords there, all the indications are there, that it'll allow you to write ES6 and yes, even ES7 features, but it'll transpile it to ES5 so it'll continue to run in all browsers. A bunch of different projects out there, a bunch of different features. Some browsers have this feature, some don't. Some have this, some don't. But if you transpile it, you will always get green all the way across. These are all things that you should be using today. I wouldn't be here giving you theoretical talks. I'm a programmer in the trenches just like you. These are all features that I'm using right now in my project today. So, without further ado, let's switch from the theoretical to the practical. Let's start looking at some of these new language features. And I mentioned earlier, but every one of these code examples you see up here will be clearly labeled. They're all coming from MDN. That's how I end up Googling JavaScript features most of the time. I'll say MDN array, and I'll get all the array documentation. And MDN module libraries. I look at Java, I look at C#, and I'm like, oh yeah, we've got these things for years. But it's nice that this is now a standard part of the library. These kinds of method calls are now available to you in every modern browser and has been since 2015. So we can start using these kinds of things. So lots of fun examples out there. Repeat is another one. How many times have you said, oh, I want to have a title, customers, and I want to have an underline that is exactly the same number of characters as that title, where you can take an underline or a dash or an equals and you can repeat it for the length of that title, and you will always get the proper number of characters. Little things like that, like I said, aren't life changers, but are nice and convenient to have on strings. Now, let me take a brief aside here and say I wasn't waiting for ECMA to add those features to my strings. I've long felt that I could just add whatever functionality I want to the string. Because JavaScript is a dynamic language, one of the things we get in a dynamic language is metaprogramming, which is dynamically adding new methods to classes on the fly at runtime. What's interesting is that would be a compiler error in Java, wouldn't it? Java would say, hey, if you try to call a method on string that doesn't exist, that's the point of a strongly typed language. Your compiler can say, that method doesn't exist. But in JavaScript, we can dynamically add that functionality on the fly. So in this example up here, we say, I've got a message called I like JavaScript. And I try to shout that message, and sure enough, the compiler yells at me, the runtime yells at me and says, ain't no method called shout on a string. At least not yet. Because when one line, by going string.prototype.shout, by adding the shout function to strings prototype, we can then turn around and shout messages all day long. This is kind of a silly, trivial example, but something I want you to keep in mind. Many of you are coming from a static language, and that's fine. I'm not here to judge. But when you start applying Java solutions to JavaScript, or more importantly, start excluding JavaScript solutions to a problem that you can't solve in Java in the same way, you're missing some of the beautiful aspects of hamsters instead of ham. You're missing the beauty of a language that can be dynamically modified at runtime. And this is the way that we could turn around and add our own starts with and ends with and includes. We don't have to wait for ECMA to add it for us. All right, so convenience methods and strings, that's all fine and good. That really didn't require any new syntax changes. They just added a couple convenience functions. But we've got a new way to define strings, and a very cool way to define strings. You probably know in JavaScript you can use a single tick to define a string, and you can use a double tick to define a string. What's the difference between the two? Absolutely nothing, right? If you're using an apostrophe somewhere and they're like, I'm with her, right? I'll probably wrap that string in double quotes so I don't have to escape out the single quote. If you're putting air quotes in a quote, he's pretty cool. I get that from my 14-year-old son a lot. Yeah, my dad, he's cool, right? If he's going to put cool in air quotes, then I'll return the entire string in single quotes again so I don't have to escape out the double quotes. But now we have a third way to define strings, backticks. There are very few characters you don't use on a regular basis. They found one, the backtick. It's right up there next to your escape key, right? And what that backtick allows you to do is define a template string. So there are a couple of interesting features about this. This template string allows you to do multi-line strings, which is very interesting. If you want to start building out templates, you could have multiple lines in there. Anything behind those grave or that backtick is considered a single string. But more importantly, we can do string interpolation. We can start adding new data inside of it. So the top example right there is how we normally do strings with the \n, add in a new line, and it's a string plus a string plus a string plus a string, string concatenation. That bottom line right there, it's hard to see from the back row, but it's using backticks. It's just a multi-line string. That is cool. That is cool. And how does Angular end up using that? Look at this. They've defined an entire template using backticks. And what that means then is they can not only have the multi-lines, but notice they didn't have to escape out any of the internal quotes, any of the single or double quotes or anything else. You can take an entire block of HTML and drop it into a variable and start using it. That is cool. That is cool. But the reason they're called template strings is because we can do string interpolation. In that bottom example, do you see the $ curly brace in there? So now instead of having to say 15 is plus an evaluation and not plus an evaluation plus, like they're doing at the top of that, in the bottom we can do that concisely all in a single string. Now, I've been doing this in Groovy for years, so I am thrilled to see this join us in JavaScript. Any Python developers in here? Python developers said, we've been doing it before Groovy's been doing it, right? So this is the beautiful thing about being a polyglot programmer. Once you find a language feature in one language you like, you can hope and wish that it'll make it into other languages. So multi-line strings from Python made it into Groovy, finally now are with us in JavaScript as well. Also in C#? Even better. Brilliant. So we've had arrays for years since ES1. But now all of a sudden we have maps and sets as well. Map is obviously a key value pair. So you can turn around and start doing maps. You can new up a new map and then you can set all day long. Again, this isn't life-changing. You're probably saying, maps, Scott, I've been having those for years. And yes, we have JSON as well, so we've been able to work around that, but now we have maps as first-class citizens, and they are welcome. They've got all the features you'd expect. Clear a map, delete a key, get all the entries, for each your way through it, everything you'd want to do. So maps, awfully nice. Now we also have sets. What's the difference between a set and an array? Help me out. What's the distinction? Sets are unique, aren't they? Arrays can have duplicates in there, but sets are a way to do singletons. So if you've been doing things in JavaScript where every time you're going to insert into an array, the first thing you do is search to make sure it wasn't already in there. If you're trying to maintain that uniqueness yourself, now you don't have to worry about it. You just new up a set, and then you put, and then anything you put into that set ends up being unique. Last one in wins. So sets are very nice because I'm doing things like we have a bunch of devices that are sending out UDP announcement packets on the wire every second. And so I had to write a whole bunch of JavaScript to get that packet off the wire, convert it from XML to JSON, but they maintain a unique list of devices. Once we got ES6 in place, I could just add those announcement packets to the set, and the set would do all the uniqueness calculations for me. So I was able to delete many lines of code by just moving from an array to a set. Fun stuff there. Looking at different sets. So there's a set right there. 1, 2, 3, 4, and 4. Yeah? But what we get in the result is simply a unique set of values, 1, 2, 3, and 4. So all the methods you'd expect to see in a map, you'll see in a set as well. All the methods you'll see in an array, you'll see in a set as well. So far, these are minor additions. You might even call this just kind of syntactic sugar. And I wouldn't argue with you. It's tasty, tasty sugar. But again, nothing is really changing the semantics of the JavaScript. Those backticks are kind of our first glimpse into new functionality. But now we have things like constants. I know. Ugh. We have constants for years in other languages, but now we have them in JavaScript as well. What's interesting about constants is that it's the variable declaration that's constant, not the payload itself. It is the left-hand side of the equation that is constant, not the right. So when we say const my fav equals 7, that's making sure you don't ever try to reassign my fav to something else. The runtime will yell at you if you try to say my fav is now 20. They said, no, once you choose a favorite number, that's your favorite number for life, right? The reason why it gets kind of confusing is what if you have a constant like my object? Well, my object then is actually a JSON object on the other side. And JavaScript is mutable. So if you turn around and start adding new fields to my object, JavaScript will happily do that because you haven't changed the assignment of that variable. That variable is still pointing to a JSON object. It just happens that JSON object is mutable because the language is mutable. So you say, well, wait a second. I was excited about constants, and now I'm not excited about constants, and it was only 60 seconds. Stick with me. You'll be excited about it once again because you can freeze your objects. And freezing works on the right-hand side of the equal sign. So if you say const pi equals 3.14 blah, 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 not only can you make sure that pi doesn't change, but the right-hand side of the equation doesn't change as well, but simply by doing a simple object freeze. So fun things to do with constants, and we're beginning to change the semantics of the language a little bit. Let is one of my favorite new features because it dramatically changes the semantics of the language. Let, in the simplest possible way to understand it, is something that you could just use anywhere you would use var. As a matter of fact, I've stopped using var almost exclusively and started using let almost exclusively, because what let does is it lexically scopes my variable declarations. Those of you who know JavaScript know that JavaScript isn't just a little bit global, is it? It's pathologically global. What happens if you declare a variable without using the var keyword? Hooray, it's global! What happens if you declare a variable with the var keyword? Hooray, it's global! Wait, what? Yeah, the only way you can not get a global variable is if you use the var keyword inside of a function. Did you catch that? If you use the var keyword inside of a function, that variable is private to the function. Anything else you do accidentally or on purpose or anything other than that will result in a global variable. If you use let, it's always private. That's what I mean by lexically scoped. Wherever you use the let keyword, whatever the nearest set of curly braces are surrounding it, that will limit the visibility of that variable. So anywhere you can use var, you should probably use let, and it'll come closer to what you probably intended to do with that variable. So when we're looking at something simple like that, if x is greater than y, guess what? We have two global variables already, don't we? X and Y. Rats. But by using that let keyword in there, let gamma equals this, gamma only exists inside of that if block. When we get out of that if block, gamma no longer exists. So I said if you use the let keyword, it's probably going to do what you're intending to do, which is lexically scope your variable to that if block. So when we look at the first example up there, var x equals 31. Okay, well that's a var keyword inside of a function, so we're good there. But then all of a sudden, what happens if we do var x later on, just 2 lines later? Well, the only scoping you have with the variable is inside of a function. So in fact, those two conflict. But if you use the let keyword, that is doing what you intended to do, which is probably not a good idea, but at least it's allowing you to syntactically do it in a valid way, which is shadow x inside of that if block. So, when you're going to do your for loops, if you do this kind of thing for let I equal 0, all of a sudden I will no longer bleed out of that for loop. You have lexically scoped it to just the life of that for loop. That's a little bit more than syntactic sugar for me. Now we're getting into the good stuff. So the let keyword, the short answer is just use it. It'll make you feel cool. Yeah? But the longer answer is use it because it's the right thing to do. Destructuring is where it gets a little bit fun. We've been talking about the left and the right-hand side of the equal sign. How many times have you had a JSON object on the right-hand side of the equal sign and you wanted to pull out just the first and the last name, or just the city and the state, or you wanted to take 5 keys over there and only pull out 2 of them over here? That's destructuring. And you just use curly braces on both sides. Now, if you're doing that with arrays or sets or maps, you will use square brackets to destructure. But I don't find myself destructuring collections very often. I find myself destructuring JSON objects all the time. So if you have a JSON object on the right, you'll use curly braces on the left, and that is a way that you will get all of those. This last example, I know it's a little bit small, but if you go A, B, and then ellipsis, the rest, you know what you end up with? You end up with a variable A, a variable B, and an array named rest that has all the other key value pairs from that JSON object. All kinds of fun things you can end up doing with that destructuring. But we see it used in Angular all the time in that import statement along the top. When you import component from Angular 2 core, what you're saying is, I want to import that class. Now, there could be multiple classes or multiple functions defined in there, and if you wanted to import more than one thing from that module, you would just say, I want to import component and base and this and that and the other, just comma delimiting that list. But here, you're using destructuring, pulling just the functions and classes you care about out of that module and being able to use it later on. Very powerful, very subtle language features. Now, arrow functions, I told you early on, were one of my favorites. They're not just arrow functions, we call them fat arrows, because an arrow would be a hyphen and a greater than, right? We don't use an arrow, we use a fat arrow. We use an equal and an arrow sign to do there. But what is it? In one sense, var is to let as function is to fat arrow. I'm going to say that again. You had var to declare variables in ES5. Now you have lets that allow you to declare variables in a lexically scoped way. In ES5, you have function, function. That's a lot of keystrokes, isn't it? So anywhere you use the function keyword, you can now use a fat arrow. And not only does that save you 6 keystrokes, it also lexically scopes that function. How many times have you made an AJAX request, and then once you got the response back, you start doing this dot first name equals and this dot last name equals inside of that response and realize this isn't doing what you wanted it to do? It's because this is no longer the person object. This is the AJAX event handler on success. Mutable this is a very controversial feature. The reason why this changes all the time is because you should be able to write a function that says make my background red, and then apply that function to every paragraph in your document, or every image in your document, or every header in your document, or every hyperlink in your document. And that's why this is mutable. That function X ends up being like a closure. When you apply that to all the paragraphs, this applies to every paragraph. So it does make sense until you're dealing with an AJAX request. You've gone off, and when the response comes back, this is the response handler, not the object you were hoping to close over. And so if you use fat arrows instead of the function keyword, lexically, you'll be closing over the person object instead of closing over the event handler. It's a fat arrow, but I highly recommend you use it because those two top and bottom examples are absolutely equivalent, but the bottom one is far more concise in making sure that that function only applies to A, not any other random this that might come into play. So, I'm sorry? How can you pass the values in function? A very good question. So, do you see set interval here with an empty array or an empty set of functions in there? You can put as many different comma delimited values in there. As a matter of fact, this is syntactic shortcut right here for just a single value, but if you included round parens in there, you could have as many different comma delimited values as you want. Very good question, very good question. So many language features, so little time. All right, I wanted to get to maybe the most exciting feature of ES6, classes. Finally, right? We have classes. I've been dipped in object-oriented concepts my whole life. From a tender young developer, they dipped me in OO and they said, everything should be an object, everything should be a class, right? Everything except JavaScript because it's a hamster, not ham. We don't get classes in JavaScript, we get functions and prototypes, and once you understand it, it's brilliant, but everyone says, can I just please have classes? It took us over 20 years, but yes, now you can finally have classes. The dirty little trick, it doesn't change the semantics of the language. JavaScript is still functions and prototypes, but you have some tasty syntactic sugar that will make JavaScript look like all of those other languages that you've been writing since a tender young age yourself. So finally, you can say class polygon, not function polygon, right? You can apply a constructor to that polygon. So now that polygon will have a height value and a width value. So it's nice being able to do these kinds of things. It's nice not only having a constructor, but being able to extend classes as well. If you have a class polygon right here that has array functions and calc area functions, well, later on, I don't have a code example of it, you could have class parallelogram, which extends class polygon and has all that function. I knew I had an example. I thought I was going crazy. So class point is the example we have here. Class point, which has some static functions on it, and then we'll get to class animal and then class dog, which extends animal. I'm not spending a whole lot of time belaboring the syntax because if you've ever used an OO language ever in your life, this is going to feel intimately familiar to you, right? And so when we go back and look at Angular 2, once again, we have a lot of people grousing about Angular 2. I can't believe they're bringing classes in. We don't need classes in JavaScript. 20 years we didn't have classes. Why do we need classes now? Guess what? It's okay. But now we have those Angular 2 examples where we have our classes that can extend other classes. That's a very, very powerful concept. If you want to call the parent class, of course, you're going to call super. You know, all these things, like I said, this should be deeply uninteresting. You've seen all the syntax before in a variety of different languages. It's now here with us in JavaScript. Modules, though, are probably the most subtle but most important addition to the language, and that's why I saved them to the very last. Because in Java, you have the ability to define packages, right? Groups of related functionality. And the reason why you define packages is so you can import them in all together. If you have a customer object, you might have a customer package that not only deals with customers, but also deals with addresses and shipping addresses and warehouse proximity and everything else that goes along with that customer. We were lacking that in JavaScript. We had script source, but that just threw everything up into the global scope. We now have modules. And here's the deal. Here's why it's so subtle. Every JS file you create now is simply a module. Every JS file you create is simply a module. There's no extra syntax. You don't wrap it in a module wrapper or anything else. Every discrete JS file you have is simply a module. And what's most important about modules is the default scope is no longer global, but private. So anything you declare in that, not if you use the var keyword, but if you use the let keyword, anything you declare in a JavaScript file will be lexically scoped to that module. Any classes you define in that JavaScript file will be lexically scoped to that module. Everything in there will be private unless you explicitly export it, which will turn around and make it such that you can import it into other modules. But this is so very different from ES5, where we would chuck all our variables into the global namespace and all of our functions into the global namespace and just hope for the best. Now we have modules that are private by default. You have to export in order to get something out of a module. You have the let keyword, which makes your variables private by default. You have to export in order to get them in. And if you don't see what a radical change this is to the language, you're missing out on what I think is the truly killer feature of ES6, is that now makes this a first-class citizen with encapsulation and imports and exports and everything else. We had to use these silly ifs earlier, immediately invoked function expressions. Wow, that's a mouthful, isn't it? These ifs mean, hey, if I declare variables like A and B, and I use the var keyword, and I want to make sure those variables don't accidentally become global, what I have to do is declare them inside of a function and then immediately execute that function. That was a lot of work, wasn't it? Now all of a sudden, we have modules where we can simply import and export. So in this one JS file right here, we are exporting a function called detectCats. We're exporting a class called kittydar. Those aren't my examples. And then we have another one called Resize Canvas. And Resize Canvas is private by default. The things that you want to export, allow other ones to use, you have to do that with intent using the export keyword. And then once you are exporting that detectCats function, you can turn around and import it using that object destructuring we discussed earlier. And if I wanted to import both detectCats and kittydar, well, I would import detectCats and kittydar. So at the end of the day, we've added some interesting new symbols, but those symbols are rich with meaning and functionality and power. And when we start looking at syntax like this, you start saying, man, why haven't we had this for years? Well, we haven't had it for years, but we have had it for a year or more in every major browser. Every major browser supports these features right now. And so when you start looking at Angular 2, you start saying, oh no, they've changed everything about this framework. Well, they did that too. But not based on the code you see up there. That code is just kind of what JavaScript looks like now. They were writing this framework for what they thought the future would look like. And the future is ES6. And the future is full of modules and classes and imports and exports and lets and consts and maps and sets and all kinds of things. This story continues to evolve. One of the things they're evaluating is doing, hey, script type equals module. If you did something like that, it would be really interesting because what it would do is it would download your JavaScript asynchronously, but it wouldn't execute. There's a way then that you can turn around and download modules and only import them and use them when you need them. So this story, even though it's a year old, is continuing to change, continuing to add new and exciting features as the language grows. There are all kinds of additional resources out there for you, but I am already out of time. So this is just a glimpse of the new curly braces and syntax you can write, but hopefully you recognize not just new syntax, but new, powerful semantics in a very familiar programming language. Did you enjoy yourself? I did as well. Thank you so much for your time and attention. I appreciate it.